Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of your exams. So today, students, we will be solving JEE 2024 29th Jan Shift 1 question paper. In this particular video, I will be solving physics part of the question paper. So here we go. Let's start with the first question of this question series of the physics part. So this question says that in the given circuit diagram, the breakdown voltage of the Zener diode is 3 volt. What is the value of IZ? So student, this question is from the chapter of electronic devices. Electronic devices. According to this question, we have to find the value of the current IZ. So IZ is the current that is going through the breakdown voltage diode. Okay, that is going through this diode. So the V voltage is given as the 10 volt. Okay, and the voltage across AB, that is breakdown voltage, is what given as 3 volt. Since it is a breakdown voltage, so the voltage across CD must be also 3 volt. Okay, if the voltage here is 3 volt, then the voltage must across CD must also have 3 volt. Okay, now since the initial voltage, the supply voltage is 10 volt, so the voltage across the resistance 1 kilo ohm resistor 1 kilo ohm should be, this is 3 volt and this is 10 volt, so this must be 7 volt. Okay, so the voltage across the resistor 1 kilo ohm is 7 volt. Okay, so we have to find the value of IZ, means the Zener current, means the current that is flowing through the Zener diode. We have to find its value IZ. Student, the supply current, it is IS, and the current flowing through this load resistance 2 kilo ohm, it is IL. And we know that IS is equals to IZ plus IL. Therefore, IZ is equals to IS minus IL. So IS is what? Uh, IS is, since from Ohm's law we know that V equals to IR. So the current across this resistor 1 kilo ohm is, so I equals to V over R. V is 7 volt and R is 1 kilo ohm. 1 kilo ohm means 7 milliampere. So IS is 7 milliampere minus IL, the current through load resistance 2 kilo ohm. Since again V equals to IR, so I equals to V over R. V means 3 volt over R is 2 kilo ohm. So current IL is equals to 1.5 milliampere. Okay. So IL is what? 1.5 milliampere. So subtracting it, we get 5.5 milliampere. So IZ current means the current that is flowing through the Zener diode is 5.5 milliampere. So our correct answer is option B, 5.5 milliampere. Okay. Now moving towards the next question, question number 32. This question says that the electric current through a wire varies with time as I equals to I naught plus beta t, where I naught is 20 ampere and beta is 3 ampere per second. The amount of electric charge crossed through a section of the wire in 20 seconds. So this question is from the chapter of current electricity. current electricity. Since we are given with the current I equals to I naught plus beta T, here I naught is 20 ampere and beta is 3 ampere per second. So I will become 20 plus 3T. Okay, 20 plus 3T. And we know that we have to find the electric charge. We know that Q is equals to integration of I dt, and it is for 20 seconds, so limit will be taken from 0 to 20. So we get Q is equals to 0 to 20 I is 20 plus 3T dt. So it will become 20T plus 3T square by 2, limit 0 to 20. So Q charge will be equals to 20 into 20 plus 3 by 2 into T square, means 20 whole square. So it will be equals to 400 plus 3 by 2 into 400. So it will be equals to 400 plus 600. So the answer is 1000 coulomb. So our charges, electric charges 1000 coulomb. So the correct answer is option B, that is 1000 coulomb. Okay. Now next question, question number 33. This question says that there are two statements. If a capillary tube is immersed first in cold water and then in hot water, the height of capillary rise will be smaller in hot water. And statement second is, if a capillary tube is immersed first in cold water and then in hot water, the height of capillary rise will be smaller in cold water. So this question is from the chapter of properties of solids and liquids. Okay. Properties of solids and liquid. According to this question, we have to find which statement is correct and which statement is false. So we know that the surface tension will be less as the temperature increases. Okay, since height is given as 2T cos theta over rho g r. So surface tension will become less when the temperature increases. So height of the capillary tube, capillary rise will be smaller in hot water and will be larger in cold water, since surface tension decreases when temperature increases. Okay, so when it is hot water, means when temperature increases, so height of capillary rise will be small. So for hot water, rise of the height of capillary rise will be small as compared to that of the cold water. So the correct option is option C, that is statement 1 is true and statement 2 is false. Now next question, question number 34. According to this question, there is a convex mirror of radius of curvature 30 centimeter forms an image that is half the size of the object. The object distance is, we have to find the object distance u. Okay, this question is from the chapter of optics. Let us draw it first. Suppose this is a convex mirror. Okay, and it is given that the it forms an image that is half the size of object. Suppose this is object and this is image size. Okay, and radius of curvature r is given 30 centimeter, means focal length is 15 centimeter. Okay, so height of image over height of object is equals to 1 by 2, since the since image is half that of the size of the object na. So magnification m is equals to minus v by u is equals to minus of 1 by 2. Okay, now for convex mirror, 1 plus v plus 1 plus u equals to 1 over f. Now let us say this is x. Okay, means distance of object is x. So Let us say distance of image is x. If distance of image is x, then the distance of object will be 2x. So 1 over b, and object is minus of 2x, 1 over x plus minus of 2x equals to 1 over 15 focal length. Okay. From here, from here, u is equals to minus of 2b, from this magnification. So if distance of image is x, so we can write, if distance of image is x, so if we can write distance of object is minus of 2x from this relation. So we write 1 over x plus 1 over minus of 2x equals to 1 over 15. So solving this, we will get 1 over x minus 1 over 2x equals to 1 over 15. So we get 2x. 2 minus 1 equals to 1 over 15. So 1 over 2x equals to 1 over 15. So x will be equals to 15 by 2. So if x image distance is 15 by 2, so the object distance will be 15 centimeter. Okay. And since object distance is minus of 2v, so object distance u will be minus of 15 centimeters. So the correct answer is u equals to minus 15 centimeter, means option A is correct, 15 minus 15 centimeter. Now next question, question number 35. This question says that two charges of 5q and minus 2q are situated at the points 3a comma 0 and minus 5a comma 0 respectively. Okay. The electric flux through a sphere of radius 4a having center at origin is. So this question is from the chapter of electrostatics. According to this question, there is a sphere and two charges 5q and minus 2q are situated at suppose this is origin point. Okay. So 5q charge is situated at 3a comma 0. 5q charge is situated at 3a comma 0 and minus 2q charge is at minus 5a comma 0. Okay. And its radius is this 4a. Okay. So the electric flux through the sphere, we know that from the Gauss law of statics, the electric flux phi is equals to 1 over epsilon naught times the total charge enclosed by the surface. This is the Gauss law of electric flux, na? The integration of E dot ds is equals to phi is equals to integration of E dot ds. It is equals to 1 upon epsilon times the total charge enclosed by the surface. So it will be 1 upon epsilon times the total charge enclosed by the surface. So the charge that is enclosed by the surface is plus of 5q. So our correct answer is 5q over epsilon naught. So correct option is option B, 5q over epsilon naught. Now question number 36. This question says that a body starts moving from rest with constant oscillation and it covers displacement S1 in first p minus 1 second and S2 in first p seconds. The displacement S1 plus S2 will be made in time. So this question is from the chapter of laws of motions. According to this question, uh, S1 displacement is made in p minus 1 second when a body starts from rest. So initial velocity is 0. So using displacement relation of the laws of motion, what is S equals to ut plus half at square. So using this, we get S1 is equals to this is 0 plus half a p minus 1 square. Since it is taking time, p minus 1 second, okay? And S2 is equals to initial velocity 0 plus half a t T is what? P second. P square. Okay. So it is asking for the displacement S1 plus S2 will be made in time. So final displacement S will be equals to S1 plus S2. It will be equals to half AT square since initial velocity is 0, since the body is starting at rest. So it will be equals to 1 by 2 A P minus 1 whole square plus 1 by 2 A P square is equals to 1 by 2 A T square. 1 by 2, 1 by 2, 1 by 2 cancels out each other. A cancels out each other. So we are left with P minus 1 whole square plus P square equals to T square. So T will be equals to under root of P minus 1 square plus P square. So it will be T is equals to under root of A square plus B square minus 2AB plus P square. So it will be equals to T is equals to under root of 2P square minus 2P plus 1. This is our final answer. So the correct option is option B. T is equals to under root of 2P square minus 2P plus 1 second. Now next question, question number 37. This question says that the potential energy function in joule of a particle in region of space is given by U is equals to 2x square plus 3y cube plus 2z. Here x, y and z are in meter. The magnitude of x component of the force in Newton acting on the particle at point 1 to 3 meter is, we have to find the magnitude of x component of force. This question is from the chapter of work, energy and power. So solving this question, we are given with potential U is equals to 2x square plus 3y cube plus 2z. Now we know that force is equals to minus of del U over del X iota cap plus del U over del Y j cap plus del U over del Z k cap. But in the question, we are asked to find the x component. So F will be equals to minus del U over del X. Okay. Now differentiating the given potential with respect to X, we get d by dx of 2x square plus 3y cube plus 2z. So it will be equals to minus 4x. So F will be equals to 4 Newton. So our answer is 4 Newton. Option C. Okay. Now next question, question number 38. This question says that resistance R is V over I, where V is given with this and I is given with this. The percentage error in the measurement of R. We have to find the percentage error. Since from Ohm's law, we know that V equals to IR. Therefore, I is equals to V over R. Okay. Okay, we have to find in error in R, na? So R is equals to V over I. Okay. R equals to V over I. Now, according to error analysis, now differentiating it, we get del R over R is equals to del V over V plus del I over I. Now the percentage error means del R over R into 100. It will be equals to del V over V. Del V is what? 5 over V is 200. So 5 over 200 plus del I over I. Delta I over I is 0.2 over 20. 0.2 over 20 into 100 because we have to find the percentage error. So it will be equals to this 7 over 200 into 100. So it will become 7 by 2 means 3.5%. So the correct answer is 3.5%, option A. Now next question, question number 39. A block of mass 100 kg slides over a distance of 10 meter on a horizontal surface. If the coefficient of friction between the surfaces is 0.4, then the work done against friction in joule. Okay. Student, this question is from the chapter of kinematics. According to this question, there is a horizontal surface. A block of mass 100 kg, this is of 100 kg, slides over a distance of 10 meter. Okay. Given coefficient of friction mu is equals to 0.4. If the block is moving in this direction, force is acting in this direction. So frictional force is moving in backward direction. Okay. So since we know that F force is equals to mu into M into G, it will be equals to 0.4 into M, 100 kg into G, 10. So it will be equals to 400 Newton. So work done W equals to F dot ds. Okay. But the frictional force is acting in opposite direction, so it will be negative of F dot ds. So it will be minus 400 into distance is what, 10 meter. So it will be equals to minus of 4000 joule. But it is asking about the magnitude, so it will be equals to 4000 joule, means option C is correct. Now question 40. Match list 1 with list 2. Okay, these equations are the Maxwell's equation. Maxwell's 4 equations, okay? Maxwell's equations. The first Maxwell's equation is what? Gauss law of electrostatics, which says that the flux phi is equals to 1 upon epsilon naught times the total charge enclosed by the surface. Means the flux, the electric flux that is passing through a closed surface is equals to 1 over epsilon naught times the total charge enclosed by the surface. So the Gauss law of electricity, it will be matched with option C. Gauss law of electricity, na, it will match with option C. Okay. Now, this is first Maxwell's equation. The second Maxwell's equation says that integration of B dot ds, means the magnetic flux passing through a closed surface is equals to 0, means B dot dA is equals to 0. So Gauss law in magnetism, the second, it will match with D. Okay. Second will match with D. And third Maxwell's equation is what? Faraday's law. This law says that the line integral of electric field is equals to del by del T of flux phi B, where phi B is equals to B dot A. B dot A. So this Faraday's law will match with option B. And the fourth Maxwell equation is modified Ampere's law. This law states that the surface integral of B dot dl is equals to mu naught times the current enclosed by the surface plus mu naught epsilon naught times del phi E over del T. So Ampere's Maxwell law, this fourth option will match with option A. So our correct option is option C. Okay. So students, our next question is question number 41. This question says that if the radius of curvature of the path of two particles of same mass are in the ratio of 3:4, then in order to have constant centripetal force, their velocities will be in the ratio of. So this question is from the chapter of laws of motion. According to this question, the radius of curvature of two particles are in the ratio of 3:4 and their mass is same. Okay. So we have to find the velocity ratio. Okay. And they have constant centripetal force. Since the centripetal force is given as centripetal force is equals to F equals to mv square over r. Okay, mv square over r. Now they are saying that they have constant centripetal force, means F1 is equals to F2 and mass is same, means M1 is equals to M2. So from F1 equals to F2 we write M1 V1 square over R1, it is equals to M2 V2 square over R2. Okay. Now mass are same. So M1, M2 cancels out each other and R1 and R2 are in the ratio of 3:4. R1, R2 equals to 3/4. So V1 square over V2 square is equals to R1 over R2. This implies that V1 over V2 is equals to under root of R1 over R2. So it will be equals to under root of 3/4, means root 3/2. So the correct answer is root 3:2, option A. Now next question, question number 42. This question says that there is a galvanometer and it is having coil resistance 10 ohm, shows a full scale deflection for a current of 3 ampere. Okay. For it to measure a current of 8 ampere, the value of shunt. We have to find the value of shunt. So student, this question is from the chapter of magnetic effects of current and magnetism. Current and magnetism. Okay. Now, according to this question, there is a galvanometer G, current I is flowing through it, and there is a shunt resistance S. When uh, a galvanometer having coil resistance 10 ohm shows a full scale deflection for the current of 3 ampere. Okay. Now, for it to measure a current of 8 ampere, so if it to measure a current of 8 ampere, let us say when I is equals to 8 ampere, we have to find the value of shunt as. Okay. And when it is current is 3 ampere, say when Ig is equals to 3 milliampere, so the resistance is 10 ohm. So we can write if Ig is across G, then across S it will be I minus Ig. If Ig current is flowing across galvanometer G, then the current across S will be this I minus Ig. So we can write S I minus Ig is equals to Ig into G. Okay. So S will be equals to Ig into G over I minus Ig. So it will become Ig 3 milliampere, 3 into 10 to the power minus 3 into G 10 over I minus Ig 8 minus 3 into 10 to the power minus 3 means 0.003. So it will be equals to 8 only, na? 3 into 10 to the power minus 3 into 10. This will be 8 only over 8. So it will be equals to 3.75 into 10 to the power minus 3 ohm. So the correct answer is 3.75 into 10 to the power minus 3 ohm. That is option C. Now next question, question number 43. According to this question, the de Broglie wavelength of an electron is same as that of a photon. If velocity of electron is 25% of the velocity of light, then the ratio of kinetic energy of electron and kinetic energy of photon. So this question is from the chapter Modern Physics. Modern Physics, okay. According to this question, for photon, let us say for photon, the de Broglie wavelength is given as lambda p equals to hc over ep. Okay, since de Broglie wavelength is lambda equals to h over p, and for photon E equals to pc, so in place of p we can write E over c, na? So ep for photon lambda equals to hc over ep, and for electron we can write for electron lambda E is equals to H over PE. It will be equals to H over over ME over VE. So it will be equals to what? HVE over 2KE. 2KE. How this 2KE comes here? Since kinetic energy equals to what? Half mv square, half mve square for electron. So mve, half mve square will be equals to 2ke. Okay. Here we have multiplied the numerator and denominator by VE. So we get HVE over MVE square. So in place of MVE square, we have written 2KE. So lambda E will be equals to HVE over 2KE. Now according to question, the velocity of electron is 25% that of the velocity of light. So velocity of electron will be 25 by 100 of C. It will be equals to 0.25 of C. So lambda E will become this. Lambda E will become H into 0.25 C over 2KE. This will be equals to HC over 8KE. Okay. This is second. Now we have to find the ratio of kinetic energy of electron and photon. So ratio of kinetic energy of electron and photon will be, since lambda P is lambda C according to the question. So HC over EP will be equals to HC over 8KE. So ratio of energy of kinetic energy of electron to that of the photon means EP is equals to 1 over 8. This is our final answer. 1 over 8. Option B is the correct answer. Now next question. Question number 44. This question says that the deflection in moving coil galvanometer falls from 25 divisions to 5 division when a shunt of 24 ohm is applied. The resistance of the galvanometer coil will be. So student, this question is again from the chapter of magnetic effects of current and magnetism. Okay. Now, according to this question, when without shunt, when no shunt is applied, when no shunt is applied, at that time, Ig is equals to, let us say 25, let us say X, where X is current per division. Okay. Current per division. They are saying it is having 25 divisions when there is no shunt. Now, when we apply a shunt across the galvanometer, when a shunt is applied, let us say this is the galvanometer G, current I is flowing through it, and when we apply a shunt, a 24 ohm resistance, it is acting over here. So Ig is equals to 5x. So this I minus Ig, if I is current is flowing through galvanometer then through shunt, current will be I minus Ig. It will be equals to 20x, 25 minus this 5x. So it will be 20x. So according to question, this 5x into G will be equals to this 20x into 24. So G will be equals to 20x into 24 over 5x. So it will be equals to 96 ohm. So our correct answer is option B, 96 ohm. Now next question, question number 45. According to this question, a biconvex lens of refractive index 1.5 has a focal length of 20 centimeter in air. Its focal length when immersed in a liquid of refractive index 1.6 will be. We have to find the focal length. We are given with a biconvex lens. Mu1 is given as 1.5. At that time, focal length is 20 centimeter. We have to find f dash when refractive index mu2 is 1 point. So student, this is a directly formula based question. The formula is 1 over f is equals to mu1 minus 1 over r1 minus 1 over r2, and 1 over f dash means new focal length is equals to mu1 over mu2 minus 1 over r1 minus r2. Now dividing these two equations 1 and 2, we get 1 over f is equals to mu1 minus 1, and 1 over f dash is equals to mu1 over mu2 minus 1. Now putting the values, f is what, 20 centimeter. So 1 over 20 equals to mu1 is 1.5 minus 1 over 1 over f dash equals to 1.5 over 1.6 minus 1. 1.5, 20 centimeter, 1.6, and f dash. Okay. So this will have 1.20 will be equals to 0.5 upon 1 over f dash is equals to 1.5 minus 1.6 over 1.5. So it will become 1 over 20 is equals to 0.5, and 1 over f dash is equals to 1.5 minus 1.6 now. So minus of 0.1 divide upon 1.5. So it will be equals to 1 over 20 into f dash is equals to 0.5 into 1.5 and minus of 0.1. So f dash will be equals to minus of 20 into 0.5 into 1.5 over 0.1. So solving this, we get f dash is equals to minus 160 centimeter. This is our final answer. F dash is equals to minus of 160 centimeter means option B is correct. Now next question 46. According to this question, a thermodynamic system is taken from an original state A to an intermediate state B by a linear process as shown in the figure. Its volume is then reduced to original value from B to C by an isobaric process. The total work done by the gas from A to B and B to C. We have to find the total work done. This question is from the chapter of thermodynamics. We have to find work done. Okay, so work done is equals to what? Integration of P dot dV. Okay, from this AC, since volume is constant, so work done by this AC is equals to 0. Now we have to find the work done by A to B and B to C, means AC work done is 0. So if we find the whole curve, we will find the work done. Okay, area under the curve, then we can find the work done. Okay, so area under the curve, work done will be equals to half into base into height. Okay, so it will be equals to half into base is what? BC. BC is what? 7 minus 3. 4 into height. Height is what? 8,000 minus 4,000 means 4,000. And it is in what? Dyne per centimeter. 1 dyne equals to 10 to the power minus 5 Newton. So it will be 10 to the power minus 5 Newton over per centimeter square means 10 to the power minus 4. So we will get, solving this, 8,000 into 10 to the power minus 5 plus 4. So it will be equals to, uh 8,000 into 10 to the power minus 1. So it will be equals to 800 joule. So the correct answer is option C, 800 joule. Now next question 47. At what distance above and below the surface of the earth the body will have same height taken radius of earth as r? We have to find the distance at which the weight of the body on the earth is same, means above and below the surface of the earth the weight of the body is same. So we have to find this distance h. Let us say this is earth, is radius, we have to take is radius r. We have to find the distance for which the height above the earth and below the surface the weight is same. Okay, For this, we will apply the formula for the gravity, and this question is from the chapter of gravitation, okay? Now, since we know that for below the surface down, for down surface, the gravity G is equals to G naught 1 minus d over r, where d is the distance below the surface of the earth, and for above the surface of the earth, g will be equals to gm over r plus d whole square. Okay, we can write g naught as on the surface of the earth, g naught as gm over r square. So solving these two we get, and weight is same. Okay, for same weight, this g naught 1 minus d over r will be equals to this gm over r plus d square. These two equation will be same for same weight. Okay, putting the value of g naught, gm over r square 1 minus d over r, it will be equals to this gm over r plus d square, cancelling gm. Now we get 1 minus d over r is equals to r over r plus d whole square. Okay, now dividing this equation by r means taking r common, so we get 1 over 1 plus d over r square equals to 1 minus d over r. Okay, let us put d over r as x. Put d over r as x. So we get 1 minus x is equals to 1 over 1 plus x square. Okay. So it means 1 minus x, it will equals to 1 over 1 plus x into 1 plus x. Now taking this from here to here, so 1 minus x will plus 1 plus x into 1 plus x, it will be equals to 1 over 1 plus x. So a minus b, a plus b, it means a square minus b square equals to 1 over 1 plus x. Okay. Now multiplying this with this, so 1 minus x square into 1 plus x, it will be equals to 1. Now solving this bracket, 1 plus x minus x square minus x cube, it will be equals to 1. 1 cancels out each other, and taking x common from here, we get 1 minus x minus of x square equals to 0. So x square plus of x minus of 1 equals to 0. Now finding its root, we get x equals to minus b plus minus under root b square minus 4ac. AC. So we will get over 2a means divided by 2. So we get x equals to minus 1 plus 4 plus 1, 5 root 2. Since x is equals to what? D over r. So d over r is equals to root 5 minus 1 by 2. So we get d distance equals to root 5 minus 1 over 2 into r. This is our final answer. So the distance at which the weight of the body is same above and below the surface of the earth is under root 2 minus 1 over 2 into r. So the correct option is what? Option D, root 5 r minus r over 2. Now question number 48. This question says that a capacitor of capacitance 100 microfarad is charged to a potential of 12 volt and connected to a 6.4 millihenry inductor to produce oscillations. The maximum current in the circuit would be. So according to this, there is a capacitor of capacitance is 100 microfarad. A voltmeter is across it having a potential of 12 volt, and it is connected to an inductor having inductance L equals to 6.4 millihenry. Okay. Now we have to find the maximum value of current in the circuit. So for maximum value of current, we will use the conservation of energy by using energy conservation. energy conservation formula. So half into CV square will be equals to half into L into maximum current square, half Li square, because we have to find maximum current. Okay. So I maximum will be equals to 1 by 2 cancels out each other. I maximum will be equals to under root of C over L into V. Now putting the value, C is 100 microfarad, means 100 into 10 to the power minus 6. And L is 6.4 millihenry, so 6.4 into 10 to the power minus 3. And V is 12. Now solving this, we get 12 by 8, which is 3 by 2, means 1.5 ampere. So the correct answer is 1.5 ampere, option B. Okay. Now, moving towards next question, question number 49. This question says that the explosive in a hydrogen bomb is a mixture of 1s2, 1s3 and 3Li6 in some condensed form. The chain reaction is given by these. During the explosion, the energy released is, we have to find the energy released. This question is from the modern physics. We have to find the amount of energy released, okay? By using these two equation, we can write the final equation as, using these two equation, and we can write the final equation as what? 3Li6 plus 1H2, okay, gives 2 2H 2He4. Okay, 1s3, 1s3 cancels out each other. 0 and 1, 0 and 1 cancels out each other, balances each other. So we get 3Li6 plus 1s2 gives 2He4. Now energy released will be equals to, delta mc square. Okay, and it means what? Energy of reactant minus energy of product, means this mass of Li plus mass of 1s2 minus 2 into mass of this 2He4. Okay. Now solving it, we get mass of Li is 6.01690 AMU plus mass of 1s2 2.01471 AMU minus mass of this 2 into 4.00388 AMU. And what is AMU? 931.5 mega electron volt. Now solving this and multiplying it with 931.5 mega electron volt, we get our answer, energy released as 22.22 mega electron volt. So the correct answer is option D, 22.22 mega electron volt. Now question 50. This question says that there are two vessels A and B. They are of same size and are at same temperature. Okay. A contains 1 gram of hydrogen and B contains 1 gram of oxygen. So P and PB are the pressures of the gases in A and B. We have to find the ratio of PA and PB. This question is from the Dalton's law of partial pressure. Dalton's law of partial pressure means from the chapter of kinetic theory of gases. Okay, this is from the chapter of kinetic theory of gases. Now solving it, since we know that PV equals to nRT, using this ideal gas equation, we get PA VA over PB VB equals to NA RTA over NB RTB. Since the temperature is same and what size is same, so Na will be equals to, not, sorry, not. Since the temperature is same and size is same, so temperature are same, gas constant is same, so size is same, so volume will become same. Therefore, PA over PB will be equals to Na over NB. Okay. 1 gram of hydrogen and 1 gram of oxygen means PA over PB will be equals to 1 gram of hydrogen means 1 by 2. 1 gram of oxygen means 1 over 32. Hydrogen means 1 into 2. It will be uh, 1 by 2, na? Then it will become 1 by 2. And oxygen O2 means 16 into 2 equals to 32. So 1 gram of oxygen means 1 by 32. So we will get 16. So PA over PB ratio is what? 16 ratio 1 means 16. So our correct answer is option A, 16. Now our next question, question number 51. This question says that when a hydrogen atom going from n equals to 2 to n equals to 1 emits a photon, its recoil speed is x by 5 meter per second. We have to find the value of x. So student, this question is from the chapter of Atomic and Nuclei Physics. According to this question, these are two energy levels. N equals to 1 correspond to energy E equals to minus 13.6 electron volt, and N equals to 2 energy level corresponds to energy E equals to minus 3.4 electron volt. We have to find the recoil speed. Okay. First of all, the energy difference between two energy state delta E is equals to 10.2 electron volt. Okay. Now the recoil speed, the direct formula for recoil speed is del V, it is equals to delta E over M into C. So V is equals to delta E is what? 10.2 electron volt divided by M into C. M is what? Mass of an electron of mass of an hydrogen atom is 1.6 into 10 to the power minus 27 into C is what? Speed of light 3 into 10 to the power 8 meter per second. So we will get this 10.2, convert this electron volt into joule. So we get 1.6 into 10 to the power minus 19 joule divided by 1.6 into 10 to the power minus 27 into 3 into 10 to the power 8. 1.6 cancels out each other, and this will become 3.4 meter per second. 3.4 meter per second means 17 by 5 meter per second. Now comparing it with the given equation, x over 5 meter per second. X over 5 meter per second. So the value of x is 17. Okay. Now next question, question number 52. According to this question, a ball rolls off the top of a stairway with horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide. The minimum velocity u with which the ball just hits the step 5 of the stairway will be root x meter per second. We have to find the value of x. This question is from the chapter of kinematics. According to this question, there are 5 steps. Okay. 1, 2, 3, 4, 5. Okay. There are 5 steps, and a ball rolls down from this with the initial velocity of u. The range of each step is 0.1 meter, and height of each step is also 0.1 meter, means 0.1 meter high and 0.1 meter wide. Okay. So we have to find the minimum velocity u with which the ball just hit, means that if the ball is coming from here, it just hit the fifth step, just hit the fifth step, means we are considering here the limiting case. Okay. Limiting case means bare minimum case, when the ball just hit the last point of the fourth step. If it is more than this, then it will come over the fifth step. We only want कि it just hit the fifth step. So for this, we will take r equals to 0.4 meter. Since there are 4 steps, 0.1 into 4, and h height is also 4 step to 0.1 1 meter into 4 equals to 0.4 meter. Okay, we are considering the limiting case for this. And we know that for such a case, R is equals to under root of 2h over g into v. So this v velocity will be equals to r into under root of g over 2h. Now solving it, r is 0.4, under root g gravity is 10 over 2 into 0.4. So this will become 0.4 over 2 into under root of 50. So this will be equal to 0.2 into under root of 50 means 0.2 into 7.07. It will be equals to 1.414, and 1.414 is what? Under root of 2 meter per second. So the value of x is 2. Okay, x equals to 2. Now, next question 53. This question says that a square loop of side 10 centimeter and resistance 0.7 ohm is placed vertically in east-west plane. A uniform magnetic field of 0.20 Tesla is set up across the plane in northeast direction. The magnetic field is decreased to 0 in 1 second at a steady rate. Then the magnitude of the induced EMF. We have to find the magnitude of the induced EMF means the value of x. Okay. Now, the question is like this. This is north, east, west, and south. This is making an angle of what? How much angle? If it is B is 0.2 Tesla, okay? If the B is 0.2 Tesla, so it is making an angle of 45 degree. If it is making an angle of 45 degree with the east, so this angle will be also A is in direction. This angle will be is also 45 degree, okay? Now, EMF, we have to find the value of EMF. EMF is equals to change in flux over change in time. So it will be equals to, since flux phi is equals to B dot A, B dot A means BA cos theta over delta T. Okay. B dot A 0.20 into A. A is what? Area. If A is taken in this direction, area is 10 centimeter. 10 centimeter means uh 10 square of area of square. Area of square is what? A square. So 10 centimeter square means 10 square. It means 100 centimeter. 100 centimeter means 100 divided by 100 centimeter square, okay, divided by 10 to the power minus into 10 to the power minus 4, okay, meter square into 10 to the power minus 4 into cos theta. Cos theta means cos 45 degree means 1 by root 2 and divided by delta t. Delta t is given as, time is given as 1 second, okay. So 1s. So solving it we get 0.20 na. Okay, so solving it we get 1.414 into 10 to the power minus 3 volt, and 1.414 is what? Under root 2 into 10 to the power minus 3 volt. So the value of x is 2. Okay. Now question number 54. This question says that a cylinder is rolling down on an inclined plane at an inclination of 60 degree. Its acceleration during rolling down will be, we have to find its acceleration. So this question is from the chapter of rotational motion, okay? Rotational motion. Now, according to this question, there is an inclined plane with an inclination of 60 degree and a cylinder is rolling down. Since student we are not given ki what type of cylinder is this, so we will always consider it as solid cylinder, okay. Whenever the in question it is not mentioned what type of sphere it is, what type of cylinder it is, so always consider the case of solid one, okay. We have to find the acceleration, so there is a direct formula for this acceleration. So for rolling motion, For rolling motion, the acceleration A is given as G sine theta over 1 plus K. Okay, where K is the moment of inertia for this solid cylinder, and here K is equals to 1 by 2. Now solving it, we get A is equals to G is 10 into sine theta sine 60 root 3 by 2 over 1 plus K, 1 plus 1 by 2. Now solving it, we get 10 by root 3. Now equating it with the given equation x over root 3. The question is asked about x over root 3. So the value of x is 10. Okay, this is our final answer. Now, question number 55. This question says that the magnetic potential due to a magnetic dipole at a point on its axis situated at a distance of 20 centimeter from its center is 1.5 into 10 to the power minus 5 Tesla meter. The magnetic moment of the dipole is, we have to find the magnetic moment, sorry, sorry, we have to find the magnetic moment. So according this question, this is from the chapter of magnetic effects of current and electricity. This is from the chapter of magnetic effect of current and magnetism. According to this question, we are given a magnetic dipole and the magnetic potential due to a matter point on its axis situate. Let us say that this is point P and the magnetic moment is in this direction. So if the magnetic moment is in this direction and we have to find the magnetic moment of the dipole at the point P, so there is a formula for this. The magnetic potential V is equals to mu naught over 4 pi m over r square. So from this m will be equals to V into 4 pi into r square over mu naught. Okay. Now solving it, we get m is equals to what? 1.5 into 10 to the power minus 5 into 20 into 20 into 10 to the power minus 4 upon 10 to the power minus 7. Since mu naught equals to 4 pi into 10 to the power minus 7 na. So mu naught over 4 pi is what? 10 to the power minus 7. So this value we have written 10 to the power minus 7. So m will be equals to 1.5 into 4. This will be equals to 6. So our answer is magnetic moment is what? 6 ampere meter square. Okay. So student, next question is question number 56. According to this question, in a double slit experiment shown in figure, when light of wavelength 400 nanometer is used, dark fringe is absorbed at point P here. If D equals to 0.2 meter, the minimum distance between the slits S1 and S2 is. So this question is from the chapter of wave optics, okay. In this question, we have to find the minimum distance, small d, between the two slits S1 and S2. Since here dark fringe is formed, dark fringe means minima condition, okay. If bright fringe is formed, we will use the condition of maxima. Since dark fringe is formed, so we will use the condition for minima, and the part different condition for minima is part difference for minima at point P, it will be equals to 2 under root of d square plus d square minus 2d equals to lambda by 2. Okay. Now, under root of d square plus d square minus of d, taking 2 common from here, it will be equals to lambda by 4. Okay. Now, under root of d square plus d square will be equals to lambda by 4 plus this d. So squaring both sides we get d square plus d square is equals to a square plus b square plus 2ab. Okay. So this will be equals to d square plus d square equals to d square plus lambda square by 16 plus lambda d over 2. Okay. Now small d square will be this d square, this square cancels out each other. It will be equals to lambda d over 2 plus lambda square over 16. Therefore, d square will be equals to, now putting these values, putting the values, we will get what? 0.2 into 400 into 10 to the power minus 9 over 2 plus lambda square. Lambda means 2 means 4 into 10 to the power minus 14 divided by 4. Okay. So we get d square is equals to 400 into 10 to the power minus 10. So d will be equals to 20 into 10 to the power minus 5. It means d is equals to 0.20 millimeter. So our answer is d is equals to 0.20 millimeter, means the distance between the slits S1 and S2 is 0.20 millimeter. Okay. Now next question, question number 57. A 16 ohm wire is bent to form a square loop. A 9-volt battery with internal resistance 1 ohm is connected across one of its sides. If a 4 microfarad capacitor is connected across one of its diagonals, the energy stored by the capacitor will be x by 2 microjoule. We have to find the value of x. So this question is from the chapter of electrostatics. Okay. According to this question, a 16 ohm wire is bent in the form of a square. Okay. So 16 ohm wire means 4 ohm, 4 ohm, this 4 ohm, and this is also 4 ohm. So 16 ohm plus 9-volt battery. 9-volt battery is in the form of like this, and this is of 1 ohm. 9-volt battery, and a capacitor is in between this, like this is point P, this is point Q. We have to find the energy stored by the capacitor. Okay. This is 4 microfarad. Okay. Now this is capacitor of capacitance 4 microfarad. Now we have to find the energy stored by the capacitor. Okay. This 3, 4 ohm, 4 ohm, 4 ohm, these 3 resistors are in series, and this one is parallel with them. So R will be equals to 4, 4, 4, 12. R equivalent will be 12 into 4 upon 12 plus 4. Since these 3 are in series, this is in parallel. So these 3 means 4 plus 4 plus 4 equals to 12. And along with 12, this register is in parallel. So R equivalent will be 12 into 4 over 12 plus 4 means 3 ohm. And there is one more resistor. It is in series with equivalence of this. So R total will be equals to 3 ohm plus 1 ohm. It will be equals to 4 ohm. Okay. Now, since the battery is of 9 volt and resistor is of 1 resistance, so current flowing in this circuit I will be equals to, since V equals to IR, so I will be equals to V over R. So V is 9 volt over R is what? 4. So I will be equals to 9 over 4 ampere. So current here is 9/4 ampere. Now this current is divided into two parts. One is going in this branch, another is going is this branch. So in this circuit, the resistance is in the ratio of 4, 4, 4, 12 or 4. Resistance is in the ratio of 12/4 means 3/1 ratio. So for this branch, the current I will be equals to what? 3/4 into 9/4 means 27/16. So current I2, let us say this is I2, this is I1. Current I2 will be flowing in this branch. It will be 27/16 ampere current. So the remaining current is flowing through this branch. So remaining current means I1 is equals to this I current minus this I2. It will be equals to 9/4 minus 27/16 means 16. 36 minus 27, it will be equals to 9/16 ampere. So the current flowing through current I1 flowing in this branch is 9/16. Okay. Now the potential at point P, and we have to find the potential at point P and potential at point Q. So the potential at point P is, since the resistor is of 4 ohm, so V equals to IR at point P. So V will be equals to, Vp will be equals to I is what? 9/16 ampere into R is 4 means 9/4 volt, and VQ current potential at this point Q. So VQ will be equals to what? 27/16 into R is what? 4. So it will be 27/4 volt. Now the potential difference between VQ and VP is VQ minus VP. It is equals to 27/4 minus 9/4 means 18/4 means 9/2 volt. So the energy stored formula is what? Energy is equals to half CV square. VQ and VP potential difference are across this capacitor, na? VQ and VP. So the energy through this capacitor will be half CV square means half into C is what? 4 into V square. V square is what? 81/4. So this will be equals to 81/2 microjoule. So the value of X is here 81. Okay. Now, next question, question 58. This question says that when the displacement of a simple harmonic oscillator is 1/3 of its amplitude, the ratio of the total energy to the kinetic energy will be. So this question is from the chapter of electrostatics. No, sorry, this question is from this chapter of oscillations and waves. Oscillations and waves. According to this question, when the amplitude becomes 1/3, when the displacement is equals to 1/3 of its amplitude, we have to find the ratio of total energy to the kinetic energy. So total energy is equals to 1/2 m omega square into a square, and kinetic energy is equals to half m v square. V is what? V square is what? Omega square a square minus x square. So v square means omega square a square minus x square. Now we have to find the ratio of this. So divide this total energy by kinetic energy. Half cancel out each other. Omega square cancels out each other. So total energy over kinetic energy, it will be equals to a square over a square minus x square. X is what? A/3. The displacement is equals to 1/3 of its amplitude, na? X equals to A/3 means a square over a square minus a square over 9. Solving it, we get a square over 9, a square minus a square, 8a square over 9. A square cancels out each other means 9/8 means 9 ratio 8. So X will be equals to 9. Now next question, question 59. An electron is moving under the influence of the electric field of a uniformly charged infinite plane sheet S having surface charge density plus sigma. The electron at t equals to 0 is at a distance of 1 meter from S and has a speed of 1 meter per second. The maximum value of sigma if the electron strikes S at t equals to 1 second is alpha m epsilon naught over E coulomb per meter square. We have to find the value of this alpha. So this question is from the chapter of electrostatics. According to this question, there is a infinite plane sheet, okay? Infinite plane sheet. An electron is moving under the influence of the electric field of this infinite plane sheet, okay? Let us say its charge density is plus sigma. At t equals to 0 second, the electron is at a distance of 1 meter from it and it is moving at the speed is 1 meter per second, okay? Since the electron is striking this plane sheet, so its distance, sorry, this is velocity, its distance will be taken as negative and acceleration will be also taken as negative. Since the force due to this plane sheet having charge density plus sigma, force will be equals to E sigma over 2 epsilon naught. Okay, so acceleration will be, since force equals to mass into acceleration, so acceleration become E sigma over 2 epsilon naught into m, but with the negative sign. Okay, so using the laws of motion equation, s equals to ut plus half at square. Okay, so s is minus 1, u is 1, moving with 1 meter per second speed, time is 1 second, minus 1 by 2, acceleration is E sigma over 2 epsilon naught into m into 1 square. Okay, into 1 square. Okay, now for time t equals to 1 second, now we have to find for time t equals to 1 second. So for t equals to 1 second, we can write this equation. So minus 1 equals to 1 minus E sigma over 4 epsilon naught m. So it will become minus 2 equals to minus E sigma over 4 epsilon naught m. Minus minus cancels out each other. So sigma will be equals to 8 epsilon naught m over E. Now comparing it with the given equation, alpha m epsilon naught over E, alpha m epsilon naught over E. So the value of alpha is what? 8. Okay. Now next question, question 60. In a text experiment on a model aeroplane in wind tunnel, the flow speeds on the upper and lower surfaces of the wings are 70 meter per second and 65 meter per second respectively. If the wing area is 2 meters square, the lift of the wing is. So this question is based on Bernoulli's principle. Okay, this is based on Bernoulli's principle and it is from the chapter of properties of solids and liquid. Solids and liquid. So a plane is moving and the speed of its upper wing and lower wing surfaces are given. Upper wing speed is given as 70 meter per second and lower surface wing is given as 65 meter per second. Okay, we have to find the, if the wing area is 2 meters square, the lift of the wing is, we have to find the lift of the wing. So the formula for this is, we have to write the formula for this. So the formula for this force, it is equals to 1 by 2 rho V1 square minus of V2 square into what? Area. Okay. How we write this formula? We write this formula as, since from Bernoulli's theorem. If we use Bernoulli's theorem, according to Bernoulli's theorem, pressure in one surface plus 1 by 2 rho into V1 square, it is equals to pressure in second surface plus 1 by 2 density, it's V2 square. So P1 minus P2, difference in pressure will be equals to 1 by 2 rho V2 square minus V1 square, and difference in pressure is what? Force equals to difference in pressure into area. So it will be equals to 1 by 2 rho V2 square minus V1 square into this area. So it will be equals to 1 by 2 into 1.2 into 70 square minus 65 square to 2. So it will be equals to 810 Newton. So force is equals to 810 Newton.